We are going to rank and analyze the top 5 most critical developments across the global technology and digital asset ecosystem.
And just to clarify the methodology here, we are strictly prioritizing systemic significance, capital momentum, regulatory shifts, and technical breakthroughs that carry immediate industry impact.
We begin our countdown at rank number 5. And this starts at the software layer, where large language models are officially transitioning from experimental conversational tools into autonomous enterprise agents.
Specifically, we are looking at the introduction of a new reference architecture called Nexus, which was developed by researcher Sandeep Nutaki.
Because up until now, attempting to deploy an autonomous AI agent in a massive enterprise environment presented severe architectural bottlenecks, right?
Very severe. You had issues with system orchestration, managing memory across thousands of internal documents, and above all else, execution reliability. But Nexus establishes a production-grade architecture to actually solve this.
So what are the practical metrics on that?
Well, when evaluated across 500 distinct enterprise tasks, so everything from complex database retrieval to integrating disparate corporate systems, Nexus achieved an 87.6% completion rate. And it did that operating with a median latency of just 1.2 seconds.
I have to push back on that right away, because an 87% success rate sounds great for a high school test. But if an AI agent is independently handling a corporation's data integration or executing supply chain orders, a 12% failure rate is a massive liability.
It is unacceptable.
Right. So how is any enterprise actually tolerating that margin of error without demanding constant human oversight?
Well, that exact concern is what keeps chief information officers up at night. And it is why the real breakthrough here is not the 87.6% success rate itself. The actual advancement is the introduction of formalized reliability semantics.
Meaning the system knows how to handle the errors.
Precisely. Nexus brings rigorous distributed systems principles into artificial intelligence. It introduces delivery guarantees that are mathematically categorized as at most once, at least once, and exactly once. Plus, it introduces production-grade circuit breakers for tool invocations.
How do those circuit breakers function in a real-world scenario?
They act as active safeguards against cascade failures. So let us say the AI agent is instructed to pull financial data from an external API, but that API goes down.
Under older models, the AI would just hallucinate an answer.
It would hallucinate, or it would freeze, or it would just repeatedly ping the API until the entire system crashed. But with Nexus, the circuit breaker identifies the failure, transitions the system state, and triggers a failure-aware replanning sequence,
Which yields a much higher reliability rate.
It achieves 94.3% tool reliability by allowing for graceful degradation rather than a total system failure. The agent knows how to safely fail and return partial, verified results. That is the absolute prerequisite for corporate deployment.
Okay, that covers the safety mechanism. But how does the agent maintain context? I mean, if it is shifting between different databases and tools, how does it know what strategy to use without completely losing the plot of the original command?
It manages that through a highly specific 3-tier memory system paired with an adaptive reasoning selector.
So it's not just cramming everything into one temporary context window.
No, Nexus splits memory into 3 distinct layers. First, you have working memory for short-term context. Second, episodic memory, which logs past interactions. And third, semantic memory, storing broad domain knowledge as vector embeddings.
And the adaptive reasoning selector.
It dynamically shifts the processing method based on the task. If it is a simple query, it uses a direct one-shot response. If it requires back-and-forth logic, it shifts to react interleaved reasoning, taking an action, observing the result, and reacting.
And for massive tasks.
It transitions to a comprehensive plan and execute strategy. It adapts in real time.
That level of autonomous execution naturally requires underlying infrastructure capable of processing high-frequency actions without human bottlenecks. Which brings us to rank number 4. The shift in decentralized market momentum. Exactly. Moving from enterprise software to financial infrastructure. Hyperliquid has now captured an astonishing 73% of the decentralized perpetual contract market.
We are looking at a platform where the order book depth is genuinely rivaling major centralized exchanges.
Total value locked reached $3.5 billion in the first half of 2026. The structural driver behind this is the February launch of HyperEVM, correct?
Yes, HyperEVM operates on a novel dual-block architecture. You have hyperblocks, handling rapid transaction execution with near-instant confirmation, and those are paired with macroblocks, which finalize batches of these transactions to provide an overriding layer of security.
And this operates on the HyperBFT proof-of-stake consensus mechanism, which has allowed the platform to generate annualized revenue exceeding $810 million.
It is a massive capital engine.
Let us unpack the technical mechanics driving those numbers. Because HyperBFT proof-of-stake is a dense concept. What does that architecture actually mean for the institutional user executing a high-volume trade?
It means they bypass the primary inefficiency of decentralized finance, which is the automated market maker, or AMM.
Right. Traditionally, decentralized exchanges rely heavily on passive liquidity pools.
Yes, users lock up their capital, and an algorithm determines the price based on the ratio of assets in the pool. It functions, but it is highly capital inefficient and prone to slippage. Hyperliquid completely bypasses AMMs.
By natively integrating the order books.
Exactly. Smart contracts deployed on HyperEVM interact directly with native spot and perpetual order books. It functions exactly like the matching engines on traditional Wall Street exchanges, but entirely on-chain. This provides deep, instantaneous liquidity and incredibly low gas fees natively.
But when you look at the economics supporting this ecosystem, 92% of the trading fees flow into an assistance fund, specifically designed to fund HYPE token buybacks on the spot market.
The tokenomics are aggressively structured, yes.
So if Hyperliquid is matching centralized exchanges in speed and volume, does that heavy reliance on a proprietary token buyback mechanism create a systemic vulnerability? I mean, if trading volumes suddenly contract, does the entire economic model just unravel?
It is a valid structural question, but the tokenomics are deliberately isolated from the protocol's structural integrity because the technical edge is built into that direct integration of EVM compatibility with native order books, the operational success of the exchange.
The execution speed and liquidity depth.
Right. All of that remains fundamentally intact regardless of the HYPE token's price action. Furthermore, the recent HIP-3 upgrade allows for permissionless perpetual market deployments.
Meaning any entity holding 1 million HYPE tokens can deploy a perpetual contract and earn up to 50% of the trading fee revenues without bearing the infrastructure costs.
Which is accelerating the growth even further.
And it is vital to contextualize this momentum against the broader digital asset macro environment. This is occurring simultaneously with 2025 U.S. Bitcoin spot ETF net inflows crossing $14.8 billion.
Vastly outpacing 2024.
Alongside Bitcoin reaching an all-time high of $123,000. Capital is clearly migrating toward decentralized execution layers. However, the explosive growth of both advanced AI agents and high-frequency financial trading platforms requires massive physical infrastructure.
Which leads directly to our third rank, the global AI compute and energy bottleneck.
The fundamental constraint on the technology sector is no longer the procurement of advanced silicon. It is the physical constraint of electricity.
And the narrative surrounding the global energy grid requires precision here. The core challenge is not a total lack of electricity supply.
Right. In the United States alone, power grids currently possess over 76 gigawatts of available capacity designated for large corporate consumers.
But the critical problem is that this capacity is structurally reserved for flexible loads, entities that can curtail their power usage at a moment's notice to stabilize the grid.
And AI data centers are entirely inflexible.
Completely.
Sure.
Processing massive volatile language models requires constant, uninterrupted power. Therefore, AI operators cannot legally or operationally tap into those stranded 76 gigawatts.
Which introduces a highly unconventional solution advanced by MARA. They are proposing a hybrid operational model utilizing Bitcoin miners as flexible power loads.
The concept being that Bitcoin miners run continuously but dynamically power down during AI workload spikes or when the broader grid faces peak demand.
And concurrently, we are tracking forced improvements in hardware efficiency, heavily evidenced by Amazon Web Services introducing the Trainium3 chip, which reportedly cuts AI data center power consumption by 40%.
Right. The hardware is becoming more efficient, but the overall demand is still scaling exponentially.
So let us consider the operational reality of this hybrid model. If AI data centers are high-speed trains that cannot be stopped without derailing a multi-million-dollar training run, and Bitcoin miners are essentially the shock absorbers built to take the violent impact of grid volatility, how realistic is this integration?
It is a fair point of friction.
AI workloads are increasingly demanding unyielding 24/7 uptime for the exact reasoning models and enterprise applications we discussed earlier.
Well, the model is not viable if you view it as just balancing numbers on a spreadsheet. Its viability relies entirely on smarter physical alignment at the facility level.
Meaning co-location.
Exactly. Emery's approach involves co-locating custom high-density mining rigs and advanced immersion cooling systems directly alongside the AI servers in the exact same facility.
How do they manage the power draw between the two?
They are developing proprietary energy management software to route electrical power dynamically in milliseconds. When AI compute demands spike, the software instantly throttles the Bitcoin mining operations, seamlessly routing the stable power supply to the AI server.
So the AI runs uninterrupted.
Right. The miners act as a massive thermodynamic buffer, absorbing the volatility and instantly monetizing the surplus energy when AI demand is low. It fundamentally transforms data center operators from pure energy consumers into dynamic load-balancing partners for the grid.
The physical expansion required to build these data centers is moving at unprecedented speed, but it is now colliding directly with severe, unyielding regulatory realities. And that brings us to rank number 2.
The European Union AI Act.
The enforcement deadline is August 2026, and the enterprise compliance data is alarming. Research indicates that as of late 2025, 53.8% of German enterprises have absolutely zero compliance measures in place.
And that is a heavily regulated cornerstone market for the European continent.
With a deadline less than 3 months away and over half of those enterprises completely unprepared, are we looking at a mandatory mass decommissioning of enterprise AI tools by August?
For non-compliant systems, mass decommissioning is the only legally viable outcome. The penalties established by the European Union are draconian. Maximum fines reach 35 million euros, or 7% of a corporation's global annual turnover, simply for engaging in prohibited AI practices.
And the EU AI Act fundamentally shifts the legal burden of proof entirely onto the deployer, right? Not just the vendor who built the software.
Yeah. Entirely onto the deployer. Getting the risk classification wrong is the primary vector of institutional liability here.
So how does that classification error actually happen in a standard corporate setting?
The systemic risk lies in the Annex III high-risk tier. This regulatory tier automatically encompasses highly common, everyday enterprise software, specifically human resources tools like automated CV screening algorithms and employee performance monitoring dashboards.
Tools that corporations adopted as standard productivity features over the last 2 years.
Right. The disconnect is that the law now explicitly classifies those productivity features as regulated liability-bearing decision-making systems. If a company misclassifies an AI-driven HR screening tool as minimal risk, when Annex III defines it as high risk, that company is operating an unclassified system without the required conformity documentation.
Exposing them directly to those 7% global turnover fines.
Exactly. Using these tools now requires strict data governance, extensive technical logging, and designed in human oversight.
Furthermore, the regulatory net extends to the foundational models themselves. The General Purpose AI, or GPAI, Code of Practice, finalized in July 2025, places strict systemic risk rules on models trained with over 10 to the power of 25 FLOPs.
And the signatory list for that code was very revealing.
Major providers like Amazon, Anthropic, Google, and OpenAI signed the code. But Meta noticeably abstained. Just to provide clear parameters, what does a threshold of 10 to the 25 FLOPs represent in practical industry terms?
Well, FLOPs, or floating point operations per second, is the standard metric for computational power. A threshold of 10 to the 25 FLOPs represents the absolute bleeding edge of the industry. It is the scale of compute required to train the massive frontier models that dictate global AI capabilities.
It isolates the hyperscalers.
Right. And by abstaining, Meta is signaling a significant divergence in how open source and proprietary developers intend to navigate European governance frameworks moving forward.
Now, the staggering compute required to cross that FLOP's threshold and the relentless financial pressure to sustain it culminates in our top story, rank number 1.
The apex player of the global AI industry.
OpenAI is currently displaying extreme financial fragility, posing a direct systemic risk to the broader technology ecosystem. They are valued at an unprecedented $300 billion, heavily backed by a complex $40 billion funding round.
But the structural engineering of that capitalization table is highly precarious. SoftBank is heavily borrowing against its own assets to supply $10 billion of that capital.
And the remaining $30 billion.
That $30 billion tranche is strictly contingent on OpenAI successfully navigating a legally treacherous conversion from a nonprofit organization to a fully for-profit entity by the end of 2025.
Wait, let me make sure I'm processing the scale of that contingency accurately. $30 billion of operating capital simply vanishes if they fail to finalize a highly complex legal restructuring in the next few months.
It vanishes, and you must weigh that fragile capitalization against their projected capital expenditures, which are frankly staggering. Internal projections indicate OpenAI will spend $320 billion on raw compute between 2025 and 2030.
They expect to pay Microsoft $13 billion for compute access in 2025 alone,
alongside billions in forward financial commitments to secondary infrastructure providers like CoreWeave.
And the industry's rapid transition to resource-intensive reasoning models is actively exacerbating this compute strain. Models like O1 and the recently confirmed successor O3 do not just retrieve information.
Right. They spend significant additional computing time generating a chain of thought before returning an answer.
Which dramatically increases mathematical accuracy, but it directly inflates inference costs. The O1 Pro API currently costs developers $150 per 1 million input tokens.
And simultaneously, the physical build-out to support these models is stalling.
The multi-billion-dollar Stargate data center project, specifically the site in Abilene, Texas, intended to house 64,000 next-generation Blackwell GPUs, is facing confirmed construction delays.
The physical bottleneck is real.
So this architecture creates immense counterparty risk. If OpenAI fails to navigate the legally complex conversion to a for-profit entity by December 2025, and subsequently loses that $30 billion funding tranche, what is the immediate blast radius for highly leveraged infrastructure partners like CoreWeave and Oracle?
The blast radius encompasses the foundational layer of the entire current technology rally. OpenAI has effectively become the central load-bearing entity for the sector's collective infrastructure debt.
Because the partners borrowed heavily to build data centers just for them.
Precisely. Consider Oracle. They have leased immense data centers from developers like Crusoe on binding 15-year terms specifically to service OpenAI's projected capacity demands. And consider CoreWeave. Their massive multi-billion-dollar debt facilities are heavily secured against their guaranteed contracts with customers, where OpenAI is rapidly becoming the dominant tenant.
So if OpenAI's cash flow halts because the funding conversion fails,
those multi-billion-dollar data center expansions suddenly lose their primary anchor tenant. This would instantly render the projected forward revenues of these infrastructure partners mathematically null. We would be looking at the potential trigger for a cascading credit crisis impacting all GPU-backed debt across the broader financial system.
it is a profound vulnerability. You are looking at an ecosystem where the continuous survival of the world's most advanced artificial intelligence companies currently relies on unsustainable debt structures, engineered simply to fund the raw compute power required to keep the server racks running.
Which forces a definitive reevaluation of the entire technology hierarchy. I mean, if the capital expenditure required to generate artificial intelligence continues to scale exponentially, the ultimate financial winners of the AI revolution may not be the software labs generating the frontier models at all.
The true systemic leverage shifts entirely to the entities that control the absolute unyielding physical constraint required to power those data centers.
Exactly. The ultimate beneficiaries will likely be the traditional utility companies and the regional energy grid operators.
We return to where we began. The global economy is not a series of isolated sectors. It is a single, continuous supply chain. A mathematical breakthrough in an AI reasoning model dictates the deployment of a GPU cluster, which demands a gigawatt of electricity, which requires a billion-dollar credit facility, which relies entirely on the regulatory compliance of the enterprise end user. When you view the landscape through this interconnected lens, the true nature of systemic risk becomes entirely visible. Global Tech Daily is an AI-powered synthesis.